Welcome. NOAA has just released its July of 2023 climate report. And the headline from it is that this was the hottest July on record, and not by a little, but by quite a long way. This video is a summary of that report. A quick summary of what you're about to see. As I said, July was the hottest July on record. Both land and ocean set new high temperatures. That's over a period of 174 years. Probably much longer than that. The mid-troposphere, i.e. the upper parts of the atmosphere, hottest July on record. Global sea ice extent was the smallest on record, which means we're continuing to lose sea ice as temperatures rise, which is not surprising. El Nino is now well established and will likely last through the Northern Hemisphere winter. The sun is very active at the moment, but we're still not at solar maximum, so that will continue to warm things up. Carbon dioxide levels, needless to say, reached new high levels for July. So let's take a look at the temperatures continent by continent. The North American continent was the second hottest on record, South America the first, Europe the 8th, Africa the first, Asia the first, and Oceania the 11th. And as I mentioned before, the oceans as a whole were the hottest ever measured. Here are the global temperatures plotted over the last 174 years. July beat the previous highest record temperature by 0.2 degrees centigrade. That's a huge amount, as you can see from the graph. Look at the point on the far right, just how much higher than any of the previous ones it is. It beat out 1998, 2010, and 2016 by quite a long way. The overall trend is still about 0.18 degrees centigrade per decade, but if this continues, then that trend will likely go up. This is a so-called percentiles map of the globe. This shows where record high and record low temperatures are. Record high temperatures are indicated by dark red, and you can see there's quite a few pixels around here that are dark red. Record low is indicated by dark blue, and there are no dark blue pixels on this map. Most of the land areas are warmer than average, much warmer than average, or record warmest. You can see there's a very large area of high temperature ocean just in the middle of the Atlantic here. There's a large area of warm water stretching from the west coast of South America all the way across the Pacific to Australia. That's El Nino, and we'll talk more about that later. Very few areas of cold on the planet, major ones being in Antarctica at the moment. Let's take a look at the Earth's atmosphere. Now, this is an area of about 4 kilometers or higher in the atmosphere where it's much colder, but you can see even here the temperature has been going up. The point on the far right is the most recent measurement, and that's the second warmest they've ever measured the troposphere, the previous one being 2016, the very strong El Nino back then. The trend in this data is 0.14 degrees centigrade per decade, and that is not quite as high as the surface temperature because, as I say, it's higher in the atmosphere, which means it's more divorced from the effects of global warming. First, let's take a look at global sea ice. This is the sum of all the sea ice around the globe, and you can see the trend is strongly down, and the most recent point is a new record low for that. The decadal trend is a loss of 2.7% of global sea ice per decade. Arctic sea ice has been the trendsetter for the last few years in the fall off of sea ice. You can see the trend here quite clearly. However, the last few years it's been slightly recovering and still well below average. Over the last few years, Antarctic sea ice has been strangely constant. However, the last couple of years that has changed and is beginning to drop off quite rapidly. The most recent measurements show a record low for Antarctic sea ice. As I said at the beginning, the El Nino is established now, and you can see this area of warm water off the west coast of South America stretching all the way nearly to Australia. And if you look on the right, there are 4 images taken a week apart, and you can see that this finger of hot water is moving further and further west and getting more established. This is likely to remain this way for at least the next 6 months. To add to our problems, the sun is not cooperating. At the moment, the Earth is approaching the sun in its elliptical orbit, so we're getting closer and getting more radiation as a result of that. At the moment, we're 151 million kilometers away from the sun, not quite at our average distance. At the closest will be on the 2nd of January 2024, when we'll be at 147 million kilometers. That's called perihelion. There, the Earth gets 7% more energy from the sun than it does at its furthest point. Solar cycle 25 is still on the rise, so the sun is more active, and so consequently we're still getting more heat from that. But then these two factors are not very large compared with the climate factors that we're generally talking about. And one of the primary factors there is carbon dioxide, and you can see it's continuing to rise, and this is the so-called Keeling curve. You can see the annual variation, which is the Earth breathing in effect. It reached its maximum level a couple of months ago and is now dropping back as the plants in the northern hemisphere start to suck in carbon dioxide to grow. It's increased by 3.2 parts per million over the same time last year, which is actually quite a large change compared with some previous months. So we should keep an eye on that. So what conclusions can we draw from all of this? The world is getting warmer and very quickly. That pace is likely to accelerate over the next 6 months because of El Nino, increasing greenhouse gases, and increasing solar heat. Sea ice is receding from both polar regions now and lowering the Earth's albedo, which is not helping either. The weather and climate is likely to get worse before it gets better, if indeed it ever gets better. So thank you for watching. Until next time, stay safe and goodbye.